Please welcome Julia Uhr from Electric Power Research Institute to talk about knowledge acquisition in AR. Please take it away.
Hi, everyone. Thanks for sticking around on Friday afternoon. I know you guys could be dipping out early to take a tour of the Winchester Mystery House, and you're not doing that. You're here with me instead, so thank you for that. I'm Julia Uhr. I'm from the Electric Power Research Institute. Sorry, need to see my slides. EPRI is the Electric Power Research Institute. We're a nonprofit organization that does research and development work for electric utilities. So we're doing things like promoting grid reliability, supporting the green energy transition, and we also sometimes do cool things with XR, which is what I'm going to talk about today. So the electric power industry is currently facing some unique problems that can be helped by XR, in my opinion. So we have high turnover and aging workforce. Those are problems for a lot of industries right now, but they are worse for electric power. The green energy transition also requires more workers, and those workers need to be trained for new jobs using new technologies. Many of these jobs are highly skilled and they're also dangerous. So things like doing maintenance on live power lines and going into underground vaults, which are energized in order to work on those are pretty dangerous jobs. One thing I'm currently working on is the Digital Worker Initiative. So this is a project where we just look at different emerging technologies that are aimed at utility field and plant workers. And many of these applications are aimed at knowledge acquisition. So we're looking into things like VR training for dangerous locations and processes. I've seen a lot of those at the conference this week. And AR for visualizations and instructions out in the field. I've also been seeing a lot of those. So the Digital Worker Initiative looks into what's effective and what's not, what provides a good return on investment, of course, and lessons learned during the actual implementation process, because oftentimes things don't go exactly as planned when they're implemented at an actual utility. So we're looking into what we can learn from those actual implementations. So a little bit about me. I'm a philosopher, lawyer, and tool maker. I got a law degree in 2016. I got an MA in philosophy in 2019, and I just finished up my PhD in engineering, basically focusing on human-computer interaction, and my dissertation was on XR epistemology. Epistemology is just a fancy philosophy word that means the study of knowledge. So I just love grad school. So the approach I take is very interdisciplinary, and I focus on the human experience, and especially knowledge and knowledge acquisition, and how that's impacted by XR user interfaces. And all of that is basically to explain why I'm now going to be talking about tiny games. This will relate back to electric power at the end, so bear with me. Tiny games are awesome. They're something I studied a lot in engineering school, and these are basically games that are tiny. They're accessible, they're cozy. They're also learning tools. You can learn to develop games and design games using tiny game engines and making tiny games. They're fun. They're more fun, I would say, than using something complicated and hard to learn like Unity. They have a lot of constraints, though. So they're aimed at making it very easy to make a very limited type of game. So for instance, you might have limited colors or limited amounts of code that you're allowed to use in your game. And the idea is that those constraints lead you to be more creative. They're also hackable, so they make it really easy to make a specific sort of game, but you can also make different sorts of games with them if you're willing to put in a lot of extra effort. And one important point about tiny games is that the design of the game engine itself often has a big impact on the design of the games that people make with it. So I'll give you some examples. Bitsy is a tiny game engine that you can use to mostly make tiny adventure games where little people move around the world and interact with things. So on the right, we have the Bitsy user interface. On the left is a game that I made with it called A Plant, which is basically about a little girl who finds a plant and no one knows what the name of it is, so they destroy it. Sad. But you can kind of see how the game looks similar and has a similar vibe to the game engine. Puzzle Script is another tiny game engine that's used mostly to make puzzle games. It has a very simplified coding language that you use to make games. The prototypical Puzzle Script game is a box-pushing game. So on the right is the user interface there. On the left is a Tamagotchi simulator that I made. So this is more of a hacky game. This isn't the sort of thing you're supposed to make with Puzzle Script, but putting in way more hours than I would have just using HTML5, I was able to make a Tamagotchi simulator using Puzzle Script. Except, of course, the Tamagotchi in this game has a lot of existential musings. Pico 8 is the last one I'll talk about. This is probably my favorite and the one I use most often. Pico 8 is going for a cozy vibe. That's its whole thing. It's cozy to go in there and edit code and make your artwork and make a game. So the game I made with Pico 8 most recently is called Prepper, and that's just a little kind of platformer game about a girl and her dog prepping for the apocalypse. All right, so now I'm going to talk about some things that I've been working on recently. Vritzy is a tiny VR game engine. So this is something I made in grad school, and it's a web app that you can use for developing tiny VR games. You start out by designing the game in a flat VR browser, and then you can test the game in VR without taking your headset off. That's what it's designed for. So this makes it easy and accessible to start learning how to make VR games. And this was made with A-Frame. I think everything I'm going to show you today was also made with A-Frame. And it's hackable, so it lets you download and edit the code. So you can really do whatever you want, although this is aimed at making very simple box-pushing games in VR. So here's a quick video of it. This is a browser window open in VR. We're adding shapes to the game on this grid. Click on a color, click on the grid. It's got different vertical levels. And that's how you add objects. You can also add doors, which take you to different levels. And these things are teleporters. That's how you move around the scene. And so then you can just click on the VR preview button, and that takes you into VR. So you can move around by clicking on those teleporters. You can push the boxes around. And this is basically aimed at making first-person VR puzzle games where you're pushing blocks around. But you can download the code and kind of turn it into whatever you want. So here's another project. This is Armos, and this is something I made when I was in grad school, but it was a collaboration with EPRI. This is augmented reality for maintenance and safety. So this is an AR application that's intended to be used by site operators at energy storage facilities. And we made this in response to some recent fires that have been caused by overheating batteries. And the aim of this application is just to give operators and first responders critical safety information when and where they need it. So here we have a guy pretending to be a site operator, and this is what it looks like in AR. It's showing you how the container is doing. These are containers that would be full of batteries. For example, at a solar facility, you need to store the electricity you're generating in batteries, and those batteries would be basically stored inside of shipping containers. And we also get some easier access to the manual relevant to this piece of equipment. And then probably the most interesting part of this demo is the X-ray view, where you can see data for each of the batteries inside the container. It alerts you if something is going wrong. But it gives you a simple data visualization telling you what's happening inside of the container. And that's really important because if you can't see it from the outside, you have to open up the container and go in there in order to check on the batteries. And opening the door lets oxygen into the containers. So if there's something overheating or you have a fire already starting, that can make it a lot worse. So there are some things I've learned from working on these projects and also from evaluating technology for the Digital Worker Initiative. First is that AR and VR can be very effective tools for acquiring knowledge. For electric power specifically, VR is great for training, especially on equipment that's too dangerous or remote for in-person training. So for us, that would be things like power lines, underground utility assets. Anything that's energized is dangerous and hard to train on. And anything in nuclear generation can benefit from VR training. AR is also great for visualizations out in the field. It improves knowledge acquisition by letting you see things that are typically invisible. So in electric power, that would be things like voltage, temperature, rights of way. You have legal rights that are hard to see. So, for example, when you're putting power lines through someone's property, you would get a right of way for a certain distance where you're allowed to trim trees and do stuff on someone else's property. And being able to visualize those in AR has actually been really valuable in terms of showing customers where their rights end and the utility's rights begin, and that can sometimes prevent things like lawsuits, which are expensive. And conductors sag and sway. So conductors sag conductors are like the power lines. They sag when they get snow on them. They sway if there's a lot of wind. It can be hard in the field to picture what's going to happen if you don't actually have those weather conditions. So visualizing that in AR can be super helpful. And also AR can give field workers instructions when and where they need them, which is very helpful for training new workers and also for capturing knowledge from the older workers. However, XR interfaces can also cause some problems for learning. And these are things I call epistemic hazards. So AR content can be a distraction. AR content can also block the user's view of important information in their physical environment that they need to have. So we see that with things like where people walk into the street because they're playing Pokemon Go. You get distracted, that's not good. So in an electric utility, that could be a problem if you have physical signage around you telling you not to go somewhere, not to touch something, what state your equipment is in. If that equipment is being blocked by your AR content, that's a problem. And that's more of a problem when the AR hardware is more invasive. So on phones, it's not that much of an issue. You can just look around your phone pretty easily. It's more of a problem on headsets because it's more of a pain to take it off to check your physical environment. It's even more of a pain if you're using contact lenses, and I assume it's very difficult if you have brain implants. So that's something to look forward to. So things about the electric power industry specifically are that workers just won't use tools that they don't want to use. We have a worker shortage, and of course a lot of people are dealing with worker shortages right now. But in the electric power industry, it is worse, and we've been dealing with it since well before the pandemic. So we're in a situation where if the end user, who would be a utility worker in this case, doesn't like the technology for whatever reason, they just aren't going to use it. So it has to save them time, or it has to be fun to use, or it has to otherwise add value to their individual lives if they're going to use it. So this is why I'm trying to apply the reasoning behind tiny games to tools for electric power workers. The design principles I'm trying to use here are that I want user interfaces to be pleasant to interact with. That's always important, but especially at electric utilities. For now, phone or tablet AR is best unless you specifically need a hands-free user interface for some reason. I like to combine a familiar flat user interface with an AR data visualization. And that's because applications have to be easy to learn quickly, and they can't add time to pre-existing processes. And you always want to have a simple user interface that's aimed at retirement age people. And those people do tend to actually like AR and VR a lot more than they like other technologies. They can be very resistant to new technology, but AR and VR have kind of a cool, fun element that I think helps with adoption over other technologies. So what I'm working on right now is TARP, the Toolkit for AR Rapid Prototyping. And this is basically a combination of VRITSI, the VR tiny game engine, and RMOS, Augmented Reality for Maintenance and Safety. And this applies the design principles I just talked about. It's a web application that lets you quickly prototype AR applications to test them out and make little demos. It's free and open source, and it's aimed specifically at electric utilities. So this is a closer up picture of the user interface. It's pretty simple. You've got 3 tabs to add text, shapes, and images. This is using very simple marker-based AR with A-frame. And you can add different markers, up to, I think, 9 markers. And then you just add shapes or pictures or whatever you want to add to them. And then you can download the application, and it'll just give you an HTML file and a PNG of the markers you're using. So the reason for making this tool is that electric utilities have a lot of potential use cases for AR, like procedure walkthroughs, data visualizations on equipment, things like that. But they need to know that there's going to be a return on investment. They need to know that workers are going to be interested in using it. And they want to know those things without spending a ton of money on having a vendor make a demo. So TARP lets those people quickly prototype and test out different use cases to start building a business case for investing in AR. TARP is easy to get started with. It's fun to use. Like the tiny game engines, it has cozy vibes. My hope is that the simple user interface of TARP will translate over into simple AR applications. So the design of TARP will influence the design of the products people make with it and the demos they decide to test out. It's also hackable. You can download the code and edit that however you want to. And I'm also hoping that the constraints of TARP will help to inspire creativity and brainstorming use cases for AR at electric utilities. And I will be testing all of that out at a conference in October. So here's a video of TARP. Here we're changing the text. Changing the shapes, moving them around. You can move around the 3D preview window with arrow keys, and then you download it. And this is something you could show on a meter. If you're doing meter inspections, the arrow just points to the next step you're supposed to do. Interesting, got some sound. Okay. So in that example, you just have an arrow pointing to the location of the thing you need to interact with next and text telling you what to do. So that's very simple. These things that I've showed you today are not fancy. They don't have interesting graphics. They're very simple. They're mostly things that I just made myself in not that much time. But they're effective as demos and as prototypes. And some other things that EPRI does with XR are a lot fancier, so I just want to mention that. We also work with vendors on big XR projects like VR training. We have VR training programs for a turbine deck, crane operation. We're working on one for fire safety for energy storage. And we have a sandbox environment, which is shown here, where you can basically set up your utility environment in VR and then use that for training. We're also working on AR procedure walkthroughs, specifically in nuclear generation. And we have a project called Operations Center of the Future, where we're looking into different ways to use AR and VR in the operations center. So, the electric power industry is more exciting than it seems like it would be. There's a lot of important work here to be done. If you're interested, if you have ideas on what we should be doing, or if you want to learn more, you should collaborate with EPRI and help us solve some interesting problems. Our website is epri.com, and my contact info is juhr@epri.com. Thanks very much. Anyone have questions? Yeah.
Julia, what about getting CAD participation from the vendors, major assets to accelerate that process? So if you want to lay down a substation, you get them to provide like surface CAD skins and allow you to go faster. Is anything happening there? Are they participating?
Yeah, some equipment vendors will give you a CAD model of the equipment when you buy the equipment. That definitely speeds up doing a VR training, for instance, on that equipment. So yeah, that's a thing that happens. There's also a lot of just scanning of the entire facility. But if you can get those things ahead of time, that's great. Yeah.
I see you were using marker-based placement. So there's a marker that helps you understand the coordinate system posed to the user relative to the content.
Yes.
Are you looking at any systems where you're looking at databases that have location information, have 1,000 assets, they know the XYZ locations of them, and kind of real-time connecting those two together?
We're looking into that, yeah. I'm working with the GIS team at EPRI on mostly digital twins is what we're looking into this
Excellent.
for. Yes, so that is something we're looking into. Those are not, the ones I'm showing here are prototypes. They're
Sure.
just like, here's a thing you could do, and we're letting people see it and interact with it. So for those, I'm just trying to make it as simple and easy as humanly possible. And I think markers are still the best way to do
Oh,
that
yeah.
because there's zero setup. But yes, we are definitely looking into GIS, digital twins, for real applications, yeah.
Nice. Thank you.